Hi and welcome to Dinesh Nayal classes. So in this video you will learn about the definition of energy, the definition of kinetic energy, as well as the formula, like the derivation of the formula of the kinetic energy, like how the kinetic energy can be obtained from the amount of work done in giving the present velocity of the body from its state of rest. So please watch the whole video for the better understanding of the chapter as well as to learn physics at home. So without wasting our time, so let's start with our class today. Energy. Energy of a body is defined as the capacity or ability of the body to do work. Now, when a body is capable of doing more work, it is said to possess more energy, and the reverse is also true. Also, energy is a scalar quantity. Now, it is a scalar quantity which have magnitude and no direction. Dimensions of energy are same as that of work, which is m1 L to the power 2 T to the power minus 2. And the units of energy is same as that of work. In SI unit, its energy is joules, and in CGS system, which is centimeter gram second, this is erg. Kinetic energy. The kinetic energy of a body is the energy possessed by the body by virtue of its motion only. Now, for example, we can take the bullet fired from a gun can pierce through a target on account of kinetic energy of the bullet. The windmill works on the kinetic energy of air. Water mill works on the kinetic energy of water. A nail driven into wooden block on account of kinetic energy of the hammer striking the nail. Now, the formula for kinetic energy. Kinetic energy of a body can be obtained by the amount of work done, or you can say calculating the amount of work done in giving the present velocity to the body from the state of rest. Now suppose you consider a body in which a force F has been applied and that body was initially at rest. Now take this diagram. Now this is like the force is applied at the body which is at rest, and this is the displacement which is produced in the body, and v is the final velocity acquired by the body. Now for this, if we take like m is the mass of the body at rest, so this is the mass of the body which is at rest. So the body is at rest, so means its initial velocity is 0. Its initial velocity u is 0. Now F is the force applied in the body. This is the force applied on the body. The force applied on the body. And let v be the velocity which is acquired by the body in moving to the distance s. This v is the velocity acquired by the body in moving to the distance s. This is the velocity acquired. Velocity acquired by the body. Now from the third equation of motion, using the third equation of motion, we know that v square minus u square equals 2as. Now this is the third equation. We know that u is 0 over here, so this v square equals 2as. Now how to get a? A will be v square by 2s by cross multiplication. You do v square by 2s, this equals a. Now this is the acceleration, the v square by 2s. Now this is the acceleration. Now we know that by the Newton's second law, F is what? F is equals ma. Okay, now substitute this a in this. So this is m v square by 2s. mv square by 2s, this is actually the force. Now what is the work done on the body? Now the work done on the body is force into displacement. So W is equals force into distance. This work done is force into distance. So substituting the formula, this is m v square by 2s into distance, that is s. Okay, now we can cancel out these s. So what is left with us is half m v square. Half m v square, this w This W is equals half mv square. This work done on the body is a measure of the kinetic energy of the body. So basically the kinetic energy of the body, the Ke of the body is what? Which is work done on the body on moving it from rest to that velocity, which is given by half mv square. So this is the kinetic energy, the derivation. Relation between kinetic energy and linear momentum. Okay, so let m be the mass of the body. Okay, v is the velocity of the body. This is, now v is the velocity of the body. We know that linear momentum is written as p. So this linear momentum p is actually a vector quantity mv. This is the linear momentum. And what is the kinetic energy? Kinetic energy is given by the formula half mv square. Now see, if we multiply this equation by m and divide by m, there will be no change. So this will be half, means 1 by 2m, m square v square. Now this m square v square is what? You can write m square v square as p square. So this is 1 by 2m p square. So this is basically p square by 2m. 2m. So kinetic energy, now this is the relation. Now kinetic energy is p square by 2m. So this is how the kinetic energy and the linear momentum are related. Kinetic energy is p square by 2m.